So for our second example, we have that a randomly selected sample of women ages 20 to 34 had a mean total cholesterol level of 179 milligrams per deciliter, which is a specific measurement that I don't know exactly what that looks like, with a standard deviation of 38.9. Assuming that these levels are normally distributed, we want to find the highest total cholesterol a woman in this group can have while remaining in the bottom 1%. That is, we want to find the value that corresponds to a cumulative area of 1%. So thinking in terms of our distribution, something like this, where our goal here is going to be to use whatever method we can to find that cutoff, to find that X value fitting our distribution. Well, again, we got that method, but truth be told, you should really get used to the calculator because the inverse normal function is more efficient for this. We will take the inverse normal here in terms of that value 0.01 and the specific distribution 179 for the mean and 38.9 for the standard deviation to get that our value is approximately 0.88.505. Where, as I said before, we have to bear in mind that the method the book uses is less precise. For one, because they're estimating with the table, and two, because they're going to be converting values like these into things with the z-score x value computation there. So it's going to be some rounding chasing along those details. And when we're dealing with numbers that are already a couple orders of magnitude bigger than the z-score to begin with, there's going to be some ambiguity there. So you may run into trouble every now and then in the homework with it wanting a number that's a bit different from what you get. Just bear in mind that that'll happen. Usually you'll be close enough for its rounding, and on exams I'll be careful about setting that stuff up so it's as unambiguous as it can be. Anyway, like I said before, this basically is what it is. Either we need a area given a value, we use our CDFs for that, or we need a value given an area, and we use our inverses for that. 5.1 through 5.3, it's all about the computation, it's all about the basic computation. 5.4 is going to be a little different. We're going to look at a really important result called the central limit theorem, which talks about these things called sampling distributions that are a bit of a shift from what we've seen, but it's really important stuff, and that's what we're moving on to next.